And now we're ready to talk about precipitation reactions. So, not all ionic compounds are water soluble. We have a set of solubility rules that let us determine whether or not something is soluble in water or not. Please do not memorize the solubility rules unless you already have them memorized or you really, really want to. They will be given to you, so you can see them on the equation sheet. They should be in section 4.2. If you look on the OpenStax textbook, they're also in the Gilbert textbook. When we talk about precipitation reactions, we should maybe define precipitate so that you know what it is. It is a solid material that forms in a precipitation reaction. So precipitate means to come out of solution. So if you form something that's a solid, right, that is not soluble, you will see like it might look cloudy if the precipitate is really fine. You might see chunks of the solid falling out of solution. You might even see a gas. So we have some examples toward the end that are special cases where the solid is not you don't get a solid as a precipitate. You get something that comes out of solution in the form of a gas. Again, and as always, let's look at an example to see what this would look like. If you mix together solutions of potassium iodide and lead nitrate, you may or may not get a reaction, but let's see what happens and then write a reaction equation for any reaction that takes place. So when you mix these together, so I'm just going to take a beaker with a solution, like I said, I drew an Erlenmeyer with a solution, an Erlenmeyer with the other solution, and dump them in and see what happens. So I think it's good to start by just asking what was in each flask, which relies on you remembering what happens when something dissolves in solution. So potassium iodide solution, well, one, I told you it was a solution, so you know that it was dissolved. Two, you could go look it up in the solubility rules and confirm that potassium iodide is dissolved in the solution. That means, because this is an ionic compound, that it exists as potassium 1 plus ions and I minus anions. In the lead nitrate flask, we have lead 2 plus and nitrate with a 1 minus. Now, we could put the 2 here for the nitrate if we needed it, right? Because each lead is going to have 2 nitrates associated with it. But for what we're going to do, we can deal with those coefficients a little bit later. So the thing that happens when you mix all of these together, every cation can pair up with every anion and vice versa. But, if a potassium and an iodide pair back up, it's a soluble compound. So they end up splitting back up because it's soluble. So we're going to swap partners for the ions and see if any of the new combinations are soluble or insoluble. So what I'm going to test is if potassium pairs up with nitrate, which was the anion from the other flask, and lead pairs up with iodide, what do my products look like? So potassium nitrate, KNO3, right, making sure for my ionic compound I have my charges balanced. This is soluble. So it's going to split back up into K plus and NO3 minus in that solution. Lead iodide, which I need 2 I minuses for the 1 lead 2 plus, so PbI2. This is insoluble. So it would form a solid. It's going to be a precipitate in this reaction. If I were to write out what happened in this reaction, I started with aqueous potassium iodide and aqueous lead nitrate. When I mixed them together, it produced lead iodide, which was a solid, and potassium nitrate, which was aqueous. Now, kind of make sure this is balanced, right? I need 2 potassium iodide, and that should balance everything if I produce 2 potassium nitrate. We call this the molecular equation because everything is in the form of a molecule. We can also, for reactions like this, simplify it, although it looks less simple when we start. What we're going to do is just kind of like explode the whole thing and write what form does this actually exist as when it's in solution, and then see if we can extract from that like the Cliff's Notes version of what really happened. So like get rid of the extraneous material. What was the main point? What was the thing that truly happened in this reaction? The first step in doing that is writing something called a full ionic equation, which is where every single piece is written the way that it exists in solution. So for potassium iodide, this is soluble. So I know that as an ionic compound, it exists as K plus and I minus. Now there are 2 of them because I had 2 potassium iodide. So 2K plus aqueous plus 2I minus aqueous. And then lead nitrate is also soluble, meaning it will be lead 2 plus aqueous plus 2 nitrates aqueous, turning into, so then when I get to the product side, I have lead iodide, finally something I don't have to break up. It exists in a solid form. I'm just going to write it that way. PbI2 solid, done. And then potassium nitrate is soluble. So 2K plus aqueous plus 2 nitrates aqueous. Full ionic equation. So much information. So many things that don't do anything, right? Look at potassium. It is K plus aqueous as a reactant and K plus aqueous as a product. Having it in here doesn't necessarily give us germane information about what took place in the reaction. So because of this, we will cancel it out to create something that we call a net ionic equation. So from the full ionic equation, if you find things that appear exactly the same on both sides, we can kind of cancel them out. So potassium was one example. Nitrate is the other thing that does not change throughout the reaction. And what we're left with is 2I minus plus lead 2 plus forming lead iodide. That is sort of the real action of what happened in this reaction. Now, the things that we canceled out, the potassium and the nitrate, we call those spectator ions, right? They just kind of sat there and watched the reaction happen. So they were spectators to the process. Something that you should note, right? What happens if both of your products are soluble? If you write a full ionic equation and start canceling things that appear the same on both sides and all of the ions cancel, we refer to that as no reaction. And sometimes you'll see the instructions tell you to just write NR if it's no reaction.